In this presentation, titled SQL, All Important Methods, with examples for machine learning and data science, we are focusing on how SQL supports real-world ML workflows. SQL is used to extract, clean, and aggregate data before feeding it into models. This is extremely important because machine learning does not start with model building. It starts with data preparation. Here are the three tables created: customers table, orders table, and sales table. In real-time projects, data is usually stored across multiple tables like this. Before building any ML model, we combine and process these tables to create structured datasets. In this slide, we're discussing data selection and filtering using select. Select is the primary SQL command used to fetch data. Instead of selecting all columns using select star, we select only relevant columns. In machine learning, feature selection is critical. We do not feed all database columns into the model. We carefully select features like purchase amount, age, region, and transaction count. Select helps extract exactly what is needed for modeling. Where? The where clause is used to filter rows based on conditions. For example, we can filter customers whose purchase amount is greater than $100. In machine learning projects, filtering is extremely important. We may want to analyze only high-value customers, only active users, or transactions within a certain period. Where helps us focus on relevant subsets of data before training models. The like operator is used for pattern matching. The percentage symbol represents any number of characters. For example, if we want customers from cities starting with san, we use like san%. In data science, like is useful for grouping customers by region, category, or product patterns. This is especially useful when working with text-based categorical features. In /not in, the in operator filters rows that match any value in a list. For example, selecting only electronics and books categories. In ML, this is useful when we want to train models only on specific product categories or exclude irrelevant classes. Between filters values within a numeric or date range. For example, selecting sales between January 1 and January 31. In machine learning, time-based filtering is very common. We create seasonal features, monthly trends, and time-based training datasets using between. Group by. Group by is one of the most powerful SQL commands for feature engineering. It groups rows and allows us to calculate aggregate values like total purchases per customer. In ML, we rarely use raw transaction-level data. Instead, we aggregate data into meaningful features such as total orders, average spending, or purchase frequency. Group by helps in customer profiling and behavioral feature creation. Count, sum, avg, min, max. These are aggregate functions used with group by. Count gives frequency. Sum gives total spending. AVG gives average behavior. Min and max show range. In ML projects, these functions help create numerical features that represent customer activity, sales performance, or engagement levels. HAVING. HAVING filters aggregated results after group by. For example, selecting customers with more than 5 orders. In machine learning, this is useful when we want to focus only on high-activity users or remove low-activity noise from datasets. Join. Join combines multiple tables together. In real projects, data is never stored in one single table. Customer data, order data, and sales data are usually separate. Join helps us combine them to create a complete dataset for machine learning. Left join keeps all rows from the left table. Right join keeps all rows from the right table. Full outer join keeps everything. In ML pipelines, join is used to enrich features from multiple sources. Case when. Case when creates categorical or binary features. For example, if total spending is above 1,000, label customer as VIP. This is feature engineering directly in SQL. Instead of doing it in Python, we can create segmentation labels inside the database itself. These engineered features improve model accuracy. Date functions. Date functions extract month, day, or weekday from a date column. In ML models, time-based features are very powerful. For example, sales may increase during weekends or holidays. By extracting month or weekday, we allow the model to learn seasonal patterns. String functions. String functions clean and transform text features. For example, extracting the email domain from customer emails. This allows us to convert raw text into structured categorical features that can be used for modeling. Create table view. Create table and create view store processed features. Instead of repeating complex SQL queries every time, we create feature tables once and reuse them. In production, ML pipelines, feature tables are stored and used for both training and inference. Window functions. Window functions are advanced SQL functions used for ranking, cumulative sums, and rolling averages. For example, ranking customers by spending or calculating rolling 7-day purchase totals. These are extremely useful in time series models and customer behavior prediction. Data sampling. Data sampling is used to create training and testing datasets. Instead of using the full dataset, we randomly sample 80% for training and 20% for testing. Sampling helps reduce computation cost and ensures proper model evaluation. Data cleaning. Data cleaning is critical before feeding data into machine learning models. Handling null values ensures no missing data errors. Removing duplicates prevents biased learning. Clean data directly improves model performance and reliability. To conclude, SQL plays a crucial role in real-time machine learning projects. Before any model is built, SQL is used for data extraction, filtering, aggregation, feature engineering, cleaning, sampling. A strong understanding of SQL makes a machine learning engineer much more effective in real-world production environments. Thanks for watching.